So, we are looking at the final properties of triangles. You looked at all of these when you did that Desmos last week. So when you were dragging the sides and seeing how big they can be, how small they could be, and then what happens if they didn't touch. So, the triangle inequality theorem says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So that's what you were looking at when you were dragging the side to see how big it could get and how little it could get. And then I asked you to make a conjecture or an idea about what was happening, and a lot of you said that either 10 plus 7 gave us 17 or 10 minus 7 gave us 3. So the 3 plus 7 got us to the 10, or the 10 plus 7 got us to the 17. Okay? Alright, so that would be each of the possibilities for adding the three sides together for this triangle here. It does say here that all three inequalities must be true. So if even one breaks, is it even worth checking the other two? No. If you can find one side of inequalities that fails, don't bother checking the other two, because you already know it's going to fail. Alright, so the triangle inequality theorem helps us find a range of possible side lengths that we can write as a compound inequality. You did this on the on the Desmos as well. So we're going to have whatever our side length is between the smallest number and the largest number. Alright. So it says D is the difference between the two sides. That was the 10 minus 7 that got us to the 3. And the S stands for the sum of the two sides. That's when we had 10 plus 7, which got us to the maximum side being 17. Alright, Dylan and Aiden, you gotta be quiet. Alright, so this is what you saw on the Desmos. If that's not working, then we get two sides that are overlapping, two sides that can't possibly touch, and then another version of them not touching here. Alright, so let's try it. It says, determine if it's possible to construct a triangle with the given side lengths. If not, explain why not. So if we've got the side lengths of 3, 12, and 17, can we form a triangle with these?
What feature?
Why not?
Because 3 plus 12 equals 15 and it's not greater than 17.
Alright, and if we find a single side that fails, is it worth trying the other two?
No.
You can if you want, but there's really no reason to. Alright, so put some kind of reasoning here, like, oops.
Plus 12 and less than.
So what you have to say is 3 plus 12 greater than 17. I'm asking that as a question. So is 15 bigger than 17?
No.
No. So this one can't possibly work. Alright, you try the next two and tell me if those could form a triangle or not.
Because
8 plus 5 is 13, which is more than 7.
And 5 plus 7 is 12, which is more than 8. And 8 plus 7 is 15, which is more than 8.
Good. You have to check all three. Just because one side works doesn't mean they all will. So you're asking, is 8 plus 5 greater than 7? Yes.
Yes.
Is 8 plus 7 greater than 5?
Yeah. Wait, what?
And then is 5 plus 7 greater than 8? You had to check all three to make sure they all worked.
Oh, I didn't know.
Just because one side works doesn't mean they all will. Alright, what about number 3?
No.
Why not?
Smallest
Ooh, 6 plus 12 is not greater than 18. But if you tried the other two, they would work.
Yeah.
Because 12 plus 18 is greater than 6. And 8 plus, what's my other one? 6 is greater than 12. So that's one of the ones where even though two of them work, one of them fails, so the whole thing fails. Okay? Alright. The next question says, describe the possible lengths of a third side of a triangle if we know two of the sides are 5 inches and 13 inches. So see if you can figure out a range, there's my keyword for you, a range of sides that the third side could be if you know two of the sides are 5 and 13. See if you can do that one.
Saying above A and under A is equal.
Perfect. So it said we do the difference of the two sides for the smallest. So the smallest it could be would be 8, but it can't be 8. It has to be just slightly more than 8. So it could be 8.1. It could be 8.6. It could be anything like that. And then it also needs to be less than the other two sides added together, which would be 18. So we could get up to 17.9 repeated. We just couldn't have 18. Because then one of them would surpass it and they would never touch. Okie dokie. Last one says, use the triangle inequality theorem to find a possible length of GH. So you know two of the sides are 15 and 24. You need to figure out what length this side GH could be. So I'm not asking what X could be, I'm asking what the length of that side could be. Alright, see if you can use the same idea to find that one. I showed you both ways of solving it. You could have first found X if you wanted.
Wait, we have to do math for this one?
Listen. You could have first found X if you wanted to, and then plugged them in to find the range. Or you could have just used these here to know that this side length was between 9 and
How
39.
you do all that, bro? I'm not counting.
Okay? So it just depends on what it's asking you to find. Alright, flip to the next page.
Please go back.
Smart stuff. It's smart. What the heck? Do you study over Megan? How'd you get 6?
Where do you see a 6?
9. 6H.
That's a G.
GH. That's the side. GH.
Oh. I'm trying to figure out how you got 6.
I cannot sit here anymore.
Why?
You.
What I do?
Alright.
Keep saying.
So, wrapping up these properties of triangles, this is the last of the stuff. This is like 6-5. So if you look in the textbook, the first page was like 6-3, and this page is like the 6-5 stuff. So, they are based on the same ideas as what we just looked at, but we're going to continue them a little bit farther.
Bro, so funny.
Alright, so the triangle longer side theorem says, if one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. Okay, a lot of words to say. If this side's bigger than this one, that angle better be bigger than the one opposite that one. Bigger side means bigger angle, which makes sense. The wider the angle is, the bigger of the side it's creating. Okay, there's a lot of side conversations and we still have stuff to get through. Okay, so the shortest side is going to have the smallest angle. The largest side is going to have the largest angle. That makes sense. This is the opposite of that here. Liam. The triangle larger angle theorem says, if one angle of a triangle is larger than another angle, then the side opposite the longer angle is larger than, or longer than, the side opposite the smallest angle. So, in the picture here, which angle, or which side is going to be the smallest? AB, because that angle's 30. And then, this side opposite the 50 is going to be bigger. I'm just trying to write it in the picture. Bigger than AB.
That's what I'm saying, bro. I literally hear that.
Alright. I just wrote bigger than AB. In the picture above it,
Wait, how do you do that? I want to learn.
in the picture above it that has the 8 and the 5, which angle is smaller? Angle.
Can't do it. Can you whistle?
A, B, or C? A. A is going to be smaller because this side length is shorter. So angle A would be the smaller angle of the two.
How? Because 50 agrees on this. Oh, wait, which one are we looking
I went to the above picture.
at?
Alright, so where it says try it, it says determine if it is possible to construct a triangle with the given side lengths. If not, explain why. So, figure out, okay, whoever's pretending to be a bird, I'm done listening to you.
That's Emily, she's blowing into her water.
Just be done.
Wait, can you teach me how to do that?
Just be done. Alright, so it says list the angles from smallest to largest for the first one. So you need to say what angle is the smallest, which one is the medium, and which one is the largest based on the side lengths.
What? You could just say the number.
Yeah, you're right.
Am I missing something?
Shortest side, smallest angle. Okay, so since this is our smallest angle, the side opposite that must be the smallest side. Then 72 came next. 72, which is angle M, made this side length LN. And then the last side we haven't used yet is our LM.
That actually makes sense.
So smallest side makes the smallest angle. Largest angle makes the largest side. Alright, we have one more theorem to look at before we finish these notes. Alright, side combos are done. Okay. The hinge theorem says if two sides of one triangle are congruent to two sides of another triangle, so in that picture it means the two that are one and the two that are the two, if those are congruent to each other, and the included angle of the first is larger than the included angle of the second, which is what we have here, this included angle of 35 is smaller than this included angle of 88.
This stuff too hard, bro. I don't know how to do it.
Okay, you have to listen first to understand. Once we know that, then we know that the third side of the first is longer than the third side of the second. Okay?
Oh.
So if this angle is smaller, we know this side is already going to be smaller than this side here. Alright. The converse of that says the exact opposite. Okay, why are you talking when I'm talking? I truly do not understand. You guys have all of work time to talk to each other. Let me have 10 minutes of your time.
Wait, when does work?
Not right now. Converse of the hinge theorem. What does converse mean?
Or verse? Like the
flip. So we switch the if and the then. So now we're saying if two sides of a triangle are congruent to two sides of another triangle, so same assumption, and the third side of the first triangle is longer than the third side of the second, which is what we have here and here, then the included angle of the first had to be bigger than the included angle of the second. So the angle that was made here at C already has to be bigger than the angle we made at F, because this side was longer than this side. And if these two sides are the same length, and that's the only thing that changed, this angle has to be bigger to have made the same triangle. Alright, so now you're going to try the last two. It says complete the statement with either greater than, less than, or equal to. See if you can do that. The measure of angle C.
Cool, bro. I just copied their answer.
Alright, so this was the converse of the hinge theorem. What was this one?
Equal. Or no, greater than.
There's absolutely no way that she posted it. I feel bad for her. I would be embarrassed.
So we know a side here and a side here. They share this side, so it's the same in both. If this angle is what we're talking about here and here,
On arrows now. I have no clue what I'm doing.
I got this part.
And angle 1 made a side that's 19, and angle 2 made a side that's 17. 2 had to be smaller than 1. Alright.
Zeros. There was an angle.